So this problem says find the equations of both tangent lines to the curve defined as x minus 1 squared plus y squared is equal to 1 that pass through the point 3 and 1. Okay, so this is a very similar problem to the problem number 8 that you have on Webwork. So what do we have here is a situation where the point that is given actually does not belong on the curve. Okay, so it's a slightly different problem from the one that we are used to, because up until now every problem where we had to find equation of a tangent line, we were given a point that belonged to the curve, right? So here, if you substitute here 3 minus 1 squared, 3 for x and y for 1 for y, 1 minus 1 squared, that's 2 squared, which is 4, plus 1 squared, which is 1. 4 plus 1 is not 1, right? So if you want to sketch this situation, I'm just going to remind you that this is an equation of a circle, right? So the equation of a circle is centered at the point x naught, y naught. So this x minus x naught squared plus y minus y naught squared is equal to r squared is an equation of a circle centered at the point x naught, y naught with radius r. So for example, something like this. So y naught, and here x naught, and then you have radius r. Okay, so with that in mind, what do we have? I have x minus 1, right? So it's centered at 1. This is the center. And then just y squared, which means y minus 0 squared. So it's centered at the point 1, 0, and it has radius 1 squared, which is 1, right? So this curve here is given by this equation x minus 1 squared plus y squared is equal to 1. Okay, this point here obviously is going to be the point 1, 1. This is the point 2, 0, right? It's centered at the point 1, 0 and has radius 1. Okay, now we want to find the equation of the tangent line that passes through the point 3 and 1. That's 3 here and this one here. So we have the following situation. We have to find here these two tangent lines. Right? So what do we know? We know that the equation of the line is given as y minus y naught is equal to m times x minus x naught, where x naught and y naught belong to the curve. Now, in order to avoid confusion between this equation and this equation, I will call this point on the curve, right, as AB. So this some point that we have to figure out how much it is. That's the whole idea, finding how much is that point on the curve where the tangent line touches that curve. Okay, so I'll call that point AB. Okay, so because this point here satisfies the equation of the tangent line, right? This can be written as y minus b, right? Y is b is equal to m times x minus a. Okay, how much is m? M is the derivative of y evaluated at the point AB. We still don't know how much is AB, but we want to figure that out. Okay, so let's find the first derivative. In order to find the first derivative, I have to use implicit differentiation. So x minus 1 squared prime plus y squared prime is equal to 1 prime. That's 2 times x minus 1 times 2 times y prime is equal to the derivative of 1 is 0. Okay, and in order to simplify our expression, I just divide the whole expression by 2, so you get x minus 1, this is plus, I'm sorry, x minus 1 plus 2y, y prime is equal to 0. Okay, from here, y prime is equal to negative x minus 1 over y. Sorry, there's a mistake here, because if I divide the whole expression by 2, just have y. Okay, and now I want to find this particular slope, so that means evaluate y prime at AB, at that point, right? So y prime evaluated at the point AB is going to be negative a minus 1 over b, or simply m is going to be, if you drop the parentheses here, 1 minus a over b. Okay, so what do we have so far? We have that the equation of the tangent line is y minus b is equal to 1 minus a over b times x minus a. Okay, now this is the equation of this tangent line. The tangent line passes through AB, that's why I can plug here A and B, right? But the tangent line also passes through the point 3 and 1. So that means that this equation is satisfied for the point with coordinates x is equal to 3 and y is equal to 1. Now I'm going to plug this point into the equation of the tangent line. So that's 1 minus b is equal to 1 minus a over b times 3 minus a. So one more time I'm going to repeat what just happened. I have found so far the equation of the tangent line based on what? On the fact that the tangent line passes through the point AB, which I'm still to determine what's the value of A and B, right? And I was able to find the derivative of the, I was able to find the slope of the tangent line by finding the derivative of the curve and evaluating it at this point AB. And that led me to here. But now the tangent line also passes through the point 3 and 1. That's given in the problem. That means that this equation here is going to be satisfied if I plug 3 for x and 1 for y. Okay, so let's solve this. This is b times 1 minus b, right? I'll multiply both sides by b is equal to 1 minus a times 3 minus a. So I have an equation with two unknowns. Okay? I cannot solve this equation because it has two unknowns. So I need to find another equation that involves a and b. So this is the whole idea, right? Where I'm going to find that second equation? Well, look at this. What is the information that I haven't used? I haven't used the idea that the point AB belongs to this curve, which means it satisfies what? It satisfies the equation that's given, the equation of the circle. So when you're gonna, again I'm repeating because AB belongs to the circle, right? It's on the circle, must satisfy its equation. So that means that I can plug a and b for x and y here. So that means a minus 1 squared plus b squared is equal to 1. And now I have system of two equations with two unknowns. If I solve, or when I'm going to solve this system of equations in two unknowns, right, I'll be able to find the point, how much is the point AB, I will be able to evaluate the slope, and our problem is done. Okay, so let us see how we're going to solve this system. Okay, so again, I'm going to repeat, we reduce this problem to solving for A and B, where these two equations are given. B times 1 minus B is equal to 1 minus A times 3 minus A. And A minus 1 squared plus B squared is equal to 1. Okay. From the first equation, if you expand this, you get B minus B squared is equal to 3 minus A, so that's 3 minus A minus 3A plus A squared. Okay, so let's simplify this a little bit. B minus B squared is equal to A squared minus 4A plus 3. Okay? So figuring out how to solve these two equations, right, needs a little bit of experience, okay? But here I need to use this equation. I need to use A minus 1 squared plus B squared is equal to 1. And use this equation here. So what is A minus 1 squared? That's A squared minus 2A plus 1 plus B squared is equal to 1. Okay, so I have my B squared, I have my A squared, I need negative 2A plus 1. Well, I'm going to borrow that negative 2A plus 1 from here, right? So B is equal to A squared minus 2A. I borrow minus 2A from here, so I'm left with negative 2A. Right? Negative 4 is negative 2A minus 2A. Plus 1, I borrow that 1 from here, so that means I'm left with 2 here, right? 1 plus 2 is 3, right? And bringing B squared on this side, I get plus B squared. But now, this whole thing is how much? By this equation, this whole thing is just 1. So I have that B is equal to 1 minus 2A plus 2, or simply B is equal to 3 minus 2A. So there you go. I have expressed one of the variables that I want to figure out in terms of the other one. So what can we do now? Well, now you can simply plug this equation back in here, let's say, and solve for A, right? If you plug this back in here, you get A squared minus 2A plus 1 plus B squared is 3 minus 2A, the whole thing squared is equal to 1. A squared minus 2A plus 1 plus 9 minus, how much is this? 4 times 3 is 12A plus 4A squared is equal to 1. And now add the terms, that's 5A minus 14A. 1 and 1 cancels out. So plus 9 is equal to 0. Okay, and this is squared here. So I can see that A being equal to 1 solves this equation, right? 5, if A is 1, so 5 minus 14 is negative 9 plus 9 is 0. That means that one of the factors is A minus 1, then the other factor is 5A. In order to get 5A squared, I need 5A times A is 5A squared. And what do I need to multiply negative 1 by to get positive 9? That's negative 9 is equal to 0. And from here I get two solutions for A. A is equal to 1 and A is equal to how much is this? 9 over 5. Right? And these two actually refer to these two solutions. As a matter of fact, there you go. This point indeed has x coordinate 1, right? And this point here, its x coordinate is going to be how much? 9 over 5. Right here. So those are the 2 points on the graph through which these two tangent lines pass by. Okay, now once you have A, you come back here to find B. From here, B is going to be equal to 3 minus 2 times 1, which is 1 again, and here B is 3 minus 18 over 5, that's negative 3, if I'm not mistaken. 15 minus 18 is negative 3 over 5, okay? So that means that these 2 points are 1, 1, and 9 over 5, and negative 3 over 5. So now just recall that this is the equation of the tangent line for the appropriate x at y. So from here, when xy or AB is equal to 1, 1, what do we get? I get y minus 1 is equal to the slope 1 minus 1 over 1 times x minus 1. 1 minus 1 is 0, which makes this whole thing 0. Y minus 1 is equal to 0. So the first equation of the tangent line is y is equal to 1. When the point on the graph is 9 over 5 and negative 3 over 5, okay, then you come here and just substitute. This is actually your A and B, right? A and B, to be more precise, sorry. So that's y plus 3 over 5 is equal to 1 minus 9 over 5 over negative 3 over 5 times x minus 9 over 5, and that's going to be is equal to, this is 5 minus 9 is negative 4 over 5 over negative 3 over 5 times x minus 9 over 5, or y plus 3 over 5 is equal to 4 over 3 x minus 9 over 5. Now, of course, you can simplify this in order to bring it into the version that Webwork wants you to write it down. So that's x minus 9 over 5 minus 3 over 5.